In a real-world dataset, numbers don't speak to you unless you make them speak. To get quick insights from the dataset, you need answers of questions like what's the mean value, how spread out the numbers are, is there a pattern, etc. etc. So in this video of Joey's Tech, we'll cover a Pandas topic, calculate descriptive statistics in Pandas. That helps you answer such questions and take your level up in Pandas. I won't hold you for long before we begin learning, so let's move to the Jupyter lab. Here we are in my Jupyter lab, in which I have created a new Jupyter notebook in which I have already written the code to create a data frame that stores banking data for 4 account types across 2 cities. This dataset holds transactions of 20 customers. It stores their transaction amounts and how many transactions they made and the type of accounts. So I'm going to quickly execute this code block so that you can see the data frame. All right. Let me do that. Here you go. This is our banking data set containing transactions of 20 customers. We'll now learn to calculate basic stats on transaction amount for this data frame. These basic stats are going to cover finding mean, median, mode, minimum, maximum, sum, and count. So let's first find mean of the transaction amount column. All right. So what we are going to write? We will write print, within brackets, we'll write mean transaction amount. And after comma, we'll write df, within square brackets, within single quotes, we'll write transaction underscore amount. And after the square brackets, we'll write dot mean. So Pandas provides the mean function using which we can calculate the mean of the values in the transaction underscore amount column. So let me run this code block. What does it say? It says key error transaction underscore amount. Okay, so I have made a mistake. Let me correct it quickly. T needs to be capital and A needs to be capital. Let me run this again. And there you go. The mean transaction amount has been calculated as 6030. And if you are relatively new to statistics and data science and you don't know what mean is, then mean is the average value in simple terms. We'll now move to finding the median of the transaction amount column. And what is median? It's the middle value in a series of numbers. So we'll write print, and within its brackets, we'll write median, comma, df, within square brackets, we'll write transaction amount, and this time I won't make the same mistake. T and A are capital, dot, and Pandas provides the median function to calculate the median value. So let's use that. And I'm going to run this code block, and there you go. This is the median value. Now we'll learn to calculate a very interesting thing. It's called mode, which actually returns a series. But let me tell you what mode is. It helps us to find the most frequent value in a column. So we are going to tweak our dataset for this a little bit. All right. What we are going to do, we are going to insert the same value at 3 places. So we are going to pick up a value. Let's say we pick up 1000, and let me replace this value over here with 1000 so that we have one more instance of 1000. And then I am going to replace this value as well with 1000. Now we have 3 instances of 1000 and it becomes the most frequent value. And mode is going to help us find 1000 because it's the most frequent value. Let me rerun this code block so that we have our new data set. Okay, we have 1000 over here, we have 1000 over here, and we have 1000 over here. Now we are going to calculate the mode. So it will be print, and within double quotes we'll write mode, comma, df, and within square brackets we'll write transaction underscore amount dot mode. Now since mode function returns a series, so we are going to use 0 within square brackets to take the most frequent value out of that series. All right, let's run this code block, and there you go. It has printed 1000 as the mode because 1000 is the most frequent value appearing in our dataset. Now we'll learn how to calculate the minimum and the maximum value of the column transaction amount. We'll simply use the function max to find the maximum value, and we'll use the function min to find the minimum value. So let's do that. We are going to write print, and within double quotes, we'll write maximum value. We'll write comma, TF. Within square brackets, within single quotes, we'll write transaction underscore amount. And after the square brackets, we'll write dot max. And here we are with our brackets. Now I'm going to copy this piece of code and paste it over here. And instead of maximum, I'll write minimum to save us a bit of time. And instead of max function, we'll write min. Let me execute this code block to show you the maximum value and the minimum value of the column transaction amount. And there you go. The minimum value comes out as 1000, whereas the maximum value comes out as 9900. The next functions that you are going to learn will be simple ones: sum and count. Sum is obviously going to give you the summation of the values in the transaction amount, and count is going to give you the number of values present in the transaction underscore amount column. So let's do that. We are going to write print, and within double quotes, we'll write sum, comma, TF. Within square brackets, we'll write transaction underscore amount dot sum. Okay, here is our function. And again, I'm going to copy and paste this code over here. And instead of sum, I'm going to use count. And instead of sum function over here, we are going to use the count function. All right. Let's execute this code block. And there you go. The sum of all the values in the transaction amount column is 116,400. And since there are 20 values present in the transaction amount column that belong to 20 customers, we have the count coming out as 20. Okay, now we learn a very important function which is known as describe. Now, describe is going to give you mean, count, standard deviation, minimum, and maximum, and percentiles all at once. So let's run this, and it's very simple to use describe. All you have to do is write the name of your data frame, which is df, and you need to write dot describe. Okay, brackets after describe are necessary, and if you run this piece of code, this simple piece of code, there you go. Describe gives you a lot of information. So describe has calculated count, mean, standard deviation, minimum, maximum, percentiles on each of the columns of this data frame that has numerical values. Since customer ID column is numerical in nature, hence describe has calculated these stats for the customer ID column as well, but in reality, it doesn't hold any significance. All right. So if you want describe to focus on a single column only, you can customize it. How? Let me show you. You are going to write df within square brackets. You'll write the column transaction amount, because I want these stats to be calculated for transaction amount column only. And after this, you are going to write dot describe. All right. Now, if you run this code, there you go. You have got these stats calculated only for the transaction underscore amount column. Okay. Let's now learn to calculate some advanced metrics such as standard deviation and skew. We'll first calculate standard deviation and variance. Since this is not a course on statistics, so we won't go deeper in the meaning of standard deviation and variance, but on a superficial level, you must know that these two represent how spread out the data values are in a data set from the average. So let's do this. To calculate standard deviation, we'll write print within brackets, within double quotes, we'll write standard deviation, comma, it will be df. Again, within single quotes, it will be transaction underscore amount dot std. Std function is going to calculate the standard deviation for us on transaction underscore amount column. We are also going to calculate the variance. So we are going to write print within double quotes, we'll write variance, comma, write TF. Within square brackets, we'll write transaction underscore amount. And after the square brackets, we'll write dot and var function we are going to use, because var is the function that calculates variance on a column that has numerical data. So let's run this block of code. There you go. We have just learned how to calculate the standard deviation of a column that has transaction data in a Pandas data frame. And also we have learned how to calculate the variance. Now, Pandas also provides us a method to calculate the skewness in the data, and that method is known as the skew function. Positive skewness means there are more extreme values above the mean, and negative skewness suggests there are more extreme values below the mean. So let's calculate the skewness. We'll write print, and within double quotes, we'll write skewness. After comma, we'll write if. Within square brackets, we'll write transaction amount, and we are going to use the skew function now, like this. Let's execute this piece of code, and there you go. The skewness comes out as negative, which suggests there are more extreme values below the mean. Cool. We now look towards calculating percentiles and quantiles. Let's talk a little bit about quantiles. Quantiles help us break down the data distribution into chunks, and it's great for box plots or outlier detection. So, quantiles basically explain what is the value below which certain percentage of data falls. So, let's learn how to calculate this metric. What we are going to do, we are going to write print, and within double quotes, we'll write 25th percentile. All right. And after comma, we are going to write TF. Within square brackets, we'll write transaction underscore amount dot quantile. And within its brackets, we are going to pass 0.25. So let me tell you that quantiles basically explain what is the value below which certain percentage of data falls. So if we run this code passing 0.25 as the value to the quantile function, we are asking for the 0.25 quantile. That means we are trying to calculate what is the value below which 25% of the transaction amounts fall. I repeat, what is the value below which 25% of the transaction amounts fall? Okay, let's do that. Let's run this piece of code. Okay, so 4,450 is the value below which 25% of the transaction amounts fall. Got it? That's the use of the quantile function. 25% of the people transacted below 4,450. Now, if we run this quantile function by passing 0.5, and we are going to write here 50th percentile, we run this. Okay. It tells us that half of the customers transacted below 6,400. All right. And it is also the median value, which falls at 50th percentile. I repeat, it says that 6,400 is the value below which 50% of the transaction amounts fall. And we can also calculate the 75th percentile by passing 0.75 over here. Okay, let's do that as well. So 8,100 is the value below which 75% of the transaction amounts fall. We ran all these functions on a single column transaction underscore amount on the entire dataset. However, we can calculate these descriptive stats on groups of data as well if we introduce groupby function in the middle. So let's create a grouped object first to create a group on city and account type using the groupby function. So we are going to write grouped equals to df dot group by, and within its brackets, we are going to pass a list that will have two columns. One will be city and another will be account underscore type. Okay, so let's run this piece of code. All right, we have our grouped object created. Now we want to calculate the mean of the transaction amount belonging to each of the individual groups of city and account type. So if we come over here to our data frame, here we have Mumbai and savings, that's one group. Mumbai and current, that's the second group. Delhi and savings is one group, and Delhi and current is another group. So let's calculate the mean. So it will be grouped within square brackets. It will be transaction underscore amount dot mean. We are going to use the mean function. Let's hit the play button, and there you go. I told you about the four groups: daily current, daily savings, Mumbai current, and Mumbai savings. And we have mean calculated of the transaction amount belonging to each of these groups. And one incredible thing in Pandas is that in one go, we can calculate multiple such stats by combining them using the ACK function. Let me show you how. So we write group within square brackets, we write transaction underscore amount, and we are going to make use of the add function that stands for aggregate, within whose brackets we pass a list in which we pass mean. We are going to calculate the mean, and let's calculate median as well, and also we are going to calculate the standard deviation. All right, three metrics, three descriptive stats are going to calculate for the transaction underscore amount belonging to each of the individual groups of city and account type. Let's run this code block. And there you go. For each of these groups of city and account type, we have mean, median, and standard deviation calculated. Let me give you a tip before you start exploring a dataset. Always use describe function in the beginning and then dive deeper using individual functions. Also, always check for missing data before running stats using df.isNaFunction.sum, this piece of code. And with this, we have come to the end of this video. You just learned to summarize a dataset from every possible angle using Pandas. Do not forget to check out my full Pandas course on YouTube to become an expert in Pandas by learning it from tip to toe. Like this video if it helped you, and subscribe to Joey's Tech for more such tutorials. I'll see you in the next video. Till then, goodbye and take very good care of yourself.